Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Rixson. This is their part number EH340, 6-wire, 625 finish. This is a top pivot. This is what would be called a power transfer top pivot. Let's do a quick visual tour of what the item is, then we'll talk about why we're looking at it. Overall length of the header portion, about 6 3/4 by about 1 1/4 inches. There is a decorative plate that will go over that. That is the 625 part of the part number. That plate should also be 6 3/4 by 1 1/4 inches, no doubt. The portion that will go in the top of the door that the pivot's going to set into, that's going to have an overall length of about 7 1/4, about 1 1/4 inches. Thickness on this is about 1/4 inch, and this is probably the same, would be my guess. Might be a little bit shy on that. It looks to be about 1/4 inch as well, maybe, like I said, just shy on that. After that, you're going to get, of course, the wires. There'll be 3 pair of wire. That's where the 6 wire comes in. We'll show how that threads through the unit in a moment. You get a couple of small screws for holding the scalp plate or the finish plate onto the header portion, and then a package of fasteners that will allow you to do this on either a wood or a steel door. Installation instructions, of course, are included. We're going to go over all of that. Why are you looking at this piece of hardware? Why would you need it? Let's talk about that. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, now why are you looking at this piece of equipment? The bottom line is you need to get low voltage into the door, is the bottom line. And why you would be doing that is very likely that you have, most certainly, a piece of electrified hardware, whether it be a lock set with electrified trim or a panic device with electrified trim, or a lock with electric latch retraction, whether it be a latch, a mortise lock, a deadbolt. An exit device can have electric latch retraction. All sorts of reasons. You could also be considering a piece of equipment that incorporates multiple functions. And a 6-wire top pivot is certainly going to do more than just on-off. You could have easily a door position switch integrated into the lock with the ability for power, obviously. Other functions that come with that would be latch bolt monitoring. The condition of the latch bolt, is it thrown or is it retracted, is another type of monitoring. Obviously, door position, is the door open or is it closed? Another thing that can be done, and interestingly enough, we helped with a project the last year where they needed power transfer hinges, just butt hinges, although they were specialty butt hinges, and they weren't doing any access control. There were no keypads and magnetic locks and things of that nature. There was the type of glass that under current will go from transparent to opaque. That'd be another interesting reason why you might need such a piece of equipment. This is very likely, powering, it could be powering an electric strike in a pair of doors. It's probably just powering a lock set would be my guess in a single door. Why 6 wires? Well, like I said earlier, you're going to want a spare pair of wires. So if your project demands 2 wires, you're going to want 4. And you'll very commonly see that you're going to not see less than 4 wires, especially in a hinge. These wires are really thin. They're really small. They are easy to break. They are hard to repair at that point. So always having a spare pair of wires would be considered industry best practice. So 6 doesn't tell me that they're wiring 6. Tells me that they need 4 wires for sure. It could just be simply some sort of monitoring over the latch bolt. You could have a deadbolt. You can have electric deadbolt, but then it has a door position switch. You're going to need to report that back so that the door knows the lock is saying, I'm closed, okay to throw the bolt out. That's more than just power on and off, is the bottom line. So having extra wires is going to be required. That's likely why you're looking at this. Now, this is what's called a center hung pivot. That means the vertical axis of pivoting goes down through the thickness of the center of the door. could be any distance really from the edge of the door. It really can't be any distance, but if you're not following the template, let's say this might be 2 3/4 from the jamb to the vertical axis of pivoting, which would be the pin. That's the vertical axis of pivoting. There are applications where clients have like a 5-foot wide door and they've kicked that over 12-inch or 18-inch or 24-inch, whatever it is. It's not uncommon at all, and the factory endorses. I would say that they endorse that sort of installation. Very typical and very common, extremely wide doors, center hung hardware is the bottom line. Recently have done a job where the client did a heavy duty center hung single acting floor closer. This door was obscenely wide. It was 79-inch or something like that. 83, 74, 79-inch. I had to have a custom overhead stop made by a manufacturer because this door was extremely heavy. We were using an EH340, and this really applies to the center hung concept. Center hung. Why did they want center hung versus offset? It was because they don't want to see the hardware, and this EH340 is used when you don't want to see the hardware but you need to transfer power. So this extremely wide door was going to be extremely heavy, 800 pounds, something like that. We used an EH340 for that, 79-inch wide or so. They kicked the pivot point over 24, 28-inch, something like that. And we didn't use a EH340. We used an EH345, a longer top pin is what we did. This was a very tall door as well. It was above 8 foot. It might have been about 9 foot. So just imagine the scope of this door. 80 inches wide, 108-inch tall, single acting, self-closing. Well, you can imagine that a door of that size is going to need to have some control over it. The closer will handle it and get it closed, but I wanted to prevent, because of the opening, when it got to 90, it had about another 20 degree or so, about 110 degree, before it's going to hit the outside corner of a wall. We definitely want to dead stop it, and 110 degree is the maximum dead stop that you'll get on any overhead holder or stop or friction device, and they probably templated it for 100 degrees, something like that. I don't recall, but it would have dead stopped before that. And why did we want that overhead stop? Well, we don't want the door running wild, is the bottom line. And I didn't like the idea of having just a floor closer mounted right into the concrete exterior pad. This is a residential application. I don't recall the state, Colorado or California. And it just seemed unsightly to have this piece of brass bolted down to the floor to stop the door. The proper hardware is to use an overhead concealed holder. Would have worked out really well for that application. Obviously, using it in conjunction with templating it for the center hung top pivot is the bottom line. No, we used surface mounted. It was required because of where this was going to be positioned. I couldn't get this installed on the door at the same time. Single acting. Even though it's center hung, the EH340 is a floor closer is a single acting unit, and worked out perfectly. So they could have used offset. What advantage would that have given them? Well, the advantage it would have given them, the disadvantage would be that you'd see the hardware. Even though they had to see some of the hardware, you're going to see the lock, etc. And one thing the client was doing was putting on an Mtech, which I think is owned by Assa Abloy. Just a passage set. A set screw holding the lever trim onto a spindle. And I said, I let the client know, I don't think that's a good idea. I don't really think that a single set screw holding lever trim on an 800-pound door is going to operate reliably. I think you're going to need something more robust. Grade 1 mortise lock that's going to take a substantially more robust fastening system for the trim. The jury's still out on that. How that's going to work out, who knows. The disadvantage is seeing the hardware. When it's offset, the advantage is it solves a big problem. This client in particular, they've got this huge door, 80-inch wide. It's going to pivot at about here. So in your mind's eye, imagine how I have to treat the stop. I've got to put a stop over here on one side, but then over here I've got to put a stop on the outside of the door. It's notoriously difficult to weather strip such doors. They're going to leak no matter what, because you don't have an elegant way to weather strip them in a long-term sense. Sure, you can add self-adhesive gasketing, things of that nature. It's just long-term, it's probably not going to be the most elegant solution. But I bet the door looks beautiful at the end of the day. It probably does. So that's the offset center hung sort of argument. That client did not electrify their opening. There was no reason to do so. Just a mechanical... I think what they installed was a deadbolt above that lever passage. I think I would have... Well, we'll see. I would have gone with something more robust. Obviously available in all of the finishes. This happens to be 625. That means 3 things. It means that it's made of solid brass, that it has a polished chrome plating, and that it has lacquer. I'm tempted to say that this is just polished stainless. That the 625 that we asked for, this is actually 629 would be my guess. That's going to fit over this unit just like that. Spindle's going to come out. You've got 2 holes here for the screws to hold the plate on. Okay, and as I draw that bolt, I'm going to drop my spindle down. And you do that with that slotted screw that's there. Really simple, really easy. Now, I think what we'll do now is let's switch to the screen view where we can take a closer look at all of the supporting information. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, here's the item that we are looking at, and let's take a look at some photos that we have posted down below. Here is the picture of the box, the label from this order, the contents of the box, header portion and the door portion. The header portion with the pin extended. By the way, that extension is, and it'll be listed in the catalog, but its maximum extension is probably about 3/4. Indeed, that's what it is, 3/4 inch. So you're going to have a 5/8 projection into the top of the door, showing the hole that will accommodate easily those 3 pair of wires. The walking beam portion, that's what controls that pin, the spindle, pardon me, the top pin going up and down, in and out. That's showing it retracted. We have the top door portion here. Its side view. Thrust bearing there. The finished plate. Again, I believe that's 629. Your wires, your 3 pair. The colors don't matter in the sense of they're just color-coded for your identification end to end. And then, of course, the screw package and your installation instructions. Okay, now let's take a look at all of the supporting documentation. Okay, let's go through these documents in no particular order. This would be the cut sheet, the EH340 center hung. We discussed that at length. Just to put a finishing touch on that, let's go to the item that we're looking at, the link here to the manufacturer's page. Pull up the full line product catalog, and then we're going to get to the pivot section. This catalog has the pivots starting at about the 138th page of the document. The point is in the beginning of the catalog, it will give us an explanation between offset and center hung. It's all where the vertical axis of pivoting is in a relationship to some reference point of the door. If it's center hung, the reference point is the center of the thickness of the door, and then the dimension from the jamb is determined per the template, but it'll always be in the center of the thickness. Does it have to be? I know that I've done unusually thick doors where I knew the client was not putting that in the center of the door. I would say it doesn't have to be, but the hardware is definitely designed for it to not carry a lateral load in that sort of fashion. So at the end of the day, I wouldn't personally feel that it's a major error or mistake, but unless there's a reason to bias it towards one side or the other, just leave it right in the center. I have had it scooched over to accommodate some weather stripping that we've put there, and that's worked out without any trouble. If it's offset, that reference point is different. It's now the face of the door on the pull side. And we can see that right here. The face of the door, or the face of the door, pardon me, the face of the door, or the face of the door, to the center line of the vertical axis of pivoting is either 3/4 inch or 1.5 inches. Those are the only two sizes that you'll get. And the difference between these two is the 3/4 inch offset is by far the most common. That's what you're going to see everywhere. Unless you specify an offset, it's going to be understood as a 3/4 inch offset. The issue with Rixson, as far as my experience goes, is that they use the term 3/4 in part numbers. So 3/4 can be an offset, or it could be part of a part number. So let's just scan through here and look. So they've got a 117-1/4. Well, you're tempted to think that 1/4 means something. No, it doesn't, in the sense that it doesn't mean anything dimensionally. It's just the part number. So as we scroll through here, there's one with a -1/2. Okay, so half of what? There is a 117, but that's a 117-1/2. The point I'm making is, and I'm going to get to it because we're in the intermediate pivots. We're going to scroll into the offset, the center hung pivots now. So here's a 127-3/4. That can be confusing because nothing on here is really 3/4 inch. That's a center hung pivot, but why they call it -3/4, I just don't know. 127-3/4, 128-3/4. There's obviously a reason for it. I just don't know what it is. 117-3/4, H117. So be mindful when you're using Rixson part numbers. Be wary. That does not mean 3/4 offset. I've bumped into that in the past, and I know very early on in my career it was something that I was confused about. Which I can tell you that it is one of the best things you can do to edify yourself is to just read the manufacturer's catalog. These people, Rixson, and all of their sister companies, have been in the business of architectural hardware for decades, and their approach to explaining it is tempered on decades of experience. So that's our application. 3/4 will be considered standard. Now, 1.5 inches, why would you use that? Well, you would use it when you need to move the vertical axis of pivoting out and further away from the face of the door. That could be because you have unusually thick casing. Here's an example. What if you wanted this door to get to 180 degree? Well, if you have a 3/4 inch offset, you're going to get out to about here before anything happens. Before that'll be your maximum degree. So when you move that vertical axis of pivoting further away, say 1.5 inches, you will then be able to get your door out and around. So if we go from 0 to 90 to 180 degree, that's why you're going to want to relocate that center line further out. It could also be that you don't have a need, and I've done this in the past. You don't have any sort of clearance problem like here, but I've done work for a client in the past where they took an 1 3/4 thick door and then applied to the face of that 3/4 inch thick something, MDF, because they were running the baseboard along the face of these relatively concealed doors. And the application would call for a standard, an otherwise standard pivot, but I didn't want the client mortising into this MDF base. So we went with an 1.5 inch pivot just to move the hardware back to get it under solid wood to mortise to. And an application of this is going to be, I can show you here. Application where you have, I'm going to scroll through this video to show you the client's application. There it is. baseboard, which is MDF. Nothing that you could screw to or mortise to.
So obviously a pair of doors, it's a...
And that's how exactly we solved the problem. And what happened was, what happened is the client did a job where they used concealed hinges. And he found out that it didn't work for his application because he wanted the doors to go past 90. And that means relocating the center line. And
so obviously a pair of doors, it's
relocating the center line is exactly what we did. And then I basically put together an AutoCAD scenario showing the client when we moved that vertical axis of pivoting, because it was stuck. Sorry, that video keeps moving on me. Was stuck with what he had in here. So we're moving the vertical axis of pivoting out here.
And what we can do is supply you with the necessary hardware to do that. You're going to see pivot point down here.
And that represented the thickness, the added 3/4 inch thickness.
Down here. Do you your best, but it would be incorrect to do so. This line represents the additional 3. The arm is going to go.
And just drawing in the pivot to show how we're going to get around that material.
Can you do it? Absolutely. Is it going to work? Use a pivot. You cannot use an invisible hinge.
So we also had another application where an 1.5" offset was used. Not we did have a clearance problem, and let's take a look at that. I'm going to pull up some pictures of that project. Now here's another application where we used an 1.5" offset bottom pivot and then 2 load-bearing 1.5" offset intermediate pivots. Now, the entire reason we had to move that vertical axis of pivoting is because this door is deeply inset into this arch, and the door is ajar, but you can see up here, that's one heck of an inset. I forget what that is, but it's about 2.5 inch. The client installed concealed hinges, just like the first client did we just looked at. He was able to get his door out to right about there, and then he couldn't get it open anymore, maybe to 95 or 100 degree. And while that was okay, it just wasn't enough. So I said, well, this is going to work perfectly. All you need is 1.5" offset to account for this deeply inset door into this arch. And actually, this is not an uncommon problem. We've had to do this in the past where there have been, frankly, rectangular, regular shaped doors within a deeply inset opening. And while it's just rectangular at the top, it's the same problem. You can only open the door so far before it hits that outside. I could search for that picture to show you, but it's just not necessary. So the bottom line is moving that vertical axis of pivoting further away from the face of the door allowed this client to get the door at least 240 degrees, and it was perfect for his application, if not all the way parallel to this oblique door, that angle that's here. Just worked perfectly for the client. Okay. That's a detour when it comes to offset and center hung, that's for sure. So let's go to the next document. This is the product catalog. This is all things pivot hardware related. I don't think that we need to dive into that anymore, but let's finish up our cut sheet, which is where we were before I went down that rabbit hole. Top pivot for power transfer. You're going to be able to fish wires through that top pin. Non-handed. Center hung is technically non-handed. This is a walking beam type pivot, which has everything to do with this. As you rotate that ball set screw, you'll lift the pin up and down. 11/16 diameter pin, 3/4 inch engagement, projection. Can be used with any center hung bottom pivot or floor closer. Order pivot set less top pivot with EH340 as a separate line. So what does that mean? So if you need to transfer power into the door, there is no way to order, say, that H28. Well, that's a bad example. There is no way to order the 117-half center hung heavy duty bottom pivot with an electrified top pivot. So what you do is you order that 117-1/2 LTP, which means less top pivot. They're going to strip out the top pivot from that otherwise complete pivot set, make the deduct, then you're going to pick up the add for the EH340 as a second line. You'll specify obviously your quantity of wires, your finish, your fastener package. Heavy duty needle bearing, I said thrust bearing earlier, that's a needle bearing. Specify your wires. You can get all of that in an Electrolinks configuration, which is just a quick connector. They can do 2-wire, and those 2 wires are 18 gauge if you happen to be doing something that requires a very heavy amperage or high inrush. 4, 6, 8, or 12 wire or 24 gauge can be ordered. So this is a TW6, I think? No, just 6W. If you needed it Electrolinks or Quick Connect, it would be QC6, and then it would have the connector. Completely concealed when the door is closed and is furnished with wood and machine screws. Let's take a look at this is the installation instructions, this is the template. The installation instructions have everything on it that the template does, dimensionally. You don't need both documents. It does tell you that you've got 24 gauge wires. Be mindful of that when you're wiring something to be sure that this isn't too thin for your application. So let's close off the template. Let's look just at the installation instructions. We went over the dimensional properties first. And what you're going to note is you've got the width, you've got the depth, you've got the thickness of the item. And it's shown here. You just, with all things Rixson, you have to study it. But I assure you, I've been studying these for years, decades in fact. All the dimensions are there. So we know that we've got on the header portion 6 3/4. There are 4 things we need to know. Let's go over those 4 things. Well, there's more than that, but it's the 6 3/4 long, 1 5/16 wide. Its thickness is going to be 9/32 from the underside of the header to the depth of the prep. You are going to need to drill this hole in the header. They say it's 1 inch diameter. Because your plate is 1 5/16 wide, I wouldn't worry about drilling this 1 1/8. So you need to know the length, the width, and the thickness, but then you need to know, where do I place it? That's not on here. It's not on here anywhere. The vertical axis of pivoting. That's where you're going to default to the hardware that you're installing it with. So let's say that we were doing a 117-half. Uh, 117-3/4. Okay, so we've got an EH340 that's going to go with this, and we're going to do an LTP on this 340 top pivot. Now, this is where it's going to tell us what our center line of our spindle is going to be. And here it is. From the jamb to the vertical axis of pivoting is 2 inch. And that would work for the 117-3/4. That'll give us that vertical axis of pivoting. So those are the 4 things that you need to know when you locate this. The door portion is the same logic. It's 1 1/4. It's 7 to 9/32. It is 1/4 inch thick. Now you know how to prep everything. Then you're going to need that hole down in the door for the spindle to come through. Then obviously your raceway to wherever the wires are going to. They tell you, well, here it says 22 gauge, and that makes sense to me. 24 gauge seems incorrect. Even though this document's 12 years old by now. When you see hardware, pardon me, when you see wiring diagrams for hardware, I don't see 24 gauge wires, I see 22 gauge. So I'd be tempted to say that these are indeed 22 gauge. Prepare door and frame per the details that we just went over. To make sure it works, that vertical axis of pivoting has to be completely plumb, all the way down to the bottom pivot. Now, you're going to have the header portion installed. The wires are going to be coming down through the top pin, and that they're going to be hanging out of the opening. So, connect the wires in the door frame and install the jamb portion with the pin retracted. Place door on the bottom pivot and raise the door so that it's within 2 feet of the top of the jamb. This is a two-person job for sure. Push wires through door portion bearing hole and connect wires in door. So the door portion, run the wires through there, connect the wires together in the door. Attach the door portion. Now you've got a bunch of wire hanging. As you then push the door, now at this point the door is hanging out of the opening, being held by someone precariously probably. You need to push the door up as you're pulling the wires down into your door to take up the slack. And when you get to the very end, be very, very careful to not pinch those wires. Raise the door to the vertical position while carefully pushing wires down inside door. Engage the top pivot pin by turning the adjusting screw clockwise. You'll drop the spindle down. Test your wires. Just do a continuity test on the wires at that point, and you're in good shape. Yeah, that's everything. That's all the documentation. Almost. There is a link below this video that I've mentioned to the manufacturer's page. From here, you can pull up not only all of the Rixson products that we sell by means of this horizontal navigation, but also a link to the manufacturer's website, as well as a link to the full product catalog. But also, for fun, there's a full product catalog from 1920. That's an interesting document. You'll be able to see, and by the time you're seeing this video, there will likely be other archival catalogs there. I know that I have some others. They're just not in the site just yet. It's a lot of work to scan those and get those uploaded. If you want to see what Rixson was doing 101 years ago at this point, there's the document. Olive knuckle hinges. Pivots. There's a number 17 pivot, 17 1/4. You can see where it all comes from at this point. You can see where it all comes from. I know they have some floor closers near the rear of the catalog. Let's take a look at those. There we go. It's number 20 and 25. Those part numbers were used very recently as well. I know the 10 and 15, which I think they call the Duo, is here. Yeah, double acting floor check. I think they call those the Duo. We can repair these if you have one of these very old units, either in a commercial application or a residential application as well. They're not uncommon to see them in residential applications. Doors between dining rooms and kitchens will have these in older home construction, obviously from the 1920s, most definitely. So fun little document there to dive into. All right, let's wrap up this video on camera. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. In conclusion, that's everything we have to say about this top pivot. Different wire configurations, different finishes, obviously. If you have any questions on how to order this, specify it, troubleshoot it, install it, please feel free to reach out to us. Thank you very much. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.